All right. Welcome to the Greener You webinar series. Our presentation today is called Energy as an Asset, Not an Expense, Undeveloped Investment Opportunities. We put together these webinars to promote sharing of best practices relating to sustainability in higher ed. I trust you're going to find this one interesting today. Before we dig in, I want to talk a little bit about logistics. The webinar today was sold out. We're excited to have so many people interested in the topic, and we really appreciate those of you that have taken time out to tune in. If you have colleagues who are unable to attend, we are going to be posting the recording of the webinar on our website and on LinkedIn, so stay tuned for that as well. We do want to address all of your questions, so we're keeping the lines of communication open so that you can type questions into the question box at any point during the presentation, and we'll get to them at the end. We are going to be keeping everyone on mute. We'll plan on ending at about 12:45 so we can have time to answer the questions. So let's get going. My name is Dave. I'm President and CEO of Greener You, and I'll be the moderator for today's webinar. Once again, welcome. Next, yeah, there we go. I'm excited to have Chris Powell, whom I'll introduce in more detail in a moment, joining us today. He's got an interesting talk for us. But first, I'm going to talk very briefly about Greener You. We believe strongly that you all in higher ed are in a unique position to lead on important issues of sustainability, most prominently climate change. And we've built this company with an aim to help you achieve those goals. We recognize that in order to help you, we've got to start by understanding your challenges, technical, institutional, operational, and otherwise, and craft solutions based on each institution's unique challenges. In doing that, we serve in various combinations of roles of planner, engineer, contractor, project manager, service contractor, communication manager, and other roles with our clients. We pride ourselves on our ability to collaborate with our clients and craft and implement solutions that are customized to their needs. We're very excited to have Chris Powell with us today because we've found him to be extremely insightful in thinking about the broad variety of challenges he faces in his role at Brown University and in crafting solutions both on his own and in collaboration with Greener You. I'm sure you're going to enjoy the talk. A little bit about Chris. He has a bachelor's degree in mechanical engineering as well as an MS and an MBA, along with 30-plus years experience in energy and greenhouse gas management. He's Assistant Vice President of Sustainable Energy and Environmental Initiatives at Brown University. In that role, he chairs Brown's Strategic Sustainability Planning and Advisory Committee and manages a $30 million campus-wide energy efficiency investment program. He was recently, a few years back in 2011, the recipient of the International Sustainable Campus Network's Excellence Award, and he currently chairs Rhode Island's Energy Efficiency and Resource Management Council, which guides the state's energy efficiency programs. With that, I'm going to turn it over to Chris and let him tell you what he's up to at Brown.
Thanks for joining us today. This is Chris Powell. Again, today this is about our really getting into the nitty-gritty of our overall energy management program here. I'm going to spend some time talking about the key elements of a successful sustainability management program, really getting away from a more of a traditional one-off project mode, really into a program mode, and really how to, when you move into that program mode, how that helps you invest in technology to really manage the data in your process to streamline how you implement your projects and meet your goals. Technology is really, in today's world, plays a critical success factor for us in making these programs work. And I'm going to talk a little bit about how you sell that vision across your university. We have multiple stakeholders, really making sure that we address a lot of needs beyond just energy efficiency improvements. So basically, we've got 6 key elements to our program. I'm going to go into these in more detail as we go through today's presentation. Team, the overall process we use to implement this, the technology we use, setting meaningful targets, really how to finance these projects, and lastly, how you sell that across your organization. So the team. So here we've got engineers, whether they're energy engineers or facilities engineers, it's up to you, but typically these are I think of them as the internal engineers you have that really understand both the buildings on campus and systems, but also the various building stakeholders throughout the campus and other challenges, and have really a good relationship with your operations staff. The other is our sustainability staff, and that is obviously myself, but it's also we have a programs coordinator who really does a great job of keeping everybody connected and manages our Brown energy efficiency software, making sure everyone has access to it, as well as relationships with our national grid to incorporate all of our rebates in this. And then we have project managers. Now, this can be, relatively speaking, this can be internal and or external. So we have both internal and external project managers. So obviously projects that can get really into a lot of detail, and we've got one lead project manager here. When we need additional resources, we typically go outside for that. In this case, Greener U does a lot of those projects for us. So we have a great relationship with them to actually go through cradle-to-grave projects where they understand our processes, how we make our decisions, and can really deal with that implementation as well as evaluation wherever you need them involved in this. And then, obviously, those key operations staff, right? You've got folks all over your campus running your buildings, whether it's HVAC staff or electrical or controls, you name it. I mean, those folks are critical to these programs. So having their leadership and supervision involved in this process, and on a building level, having various operations staff who understand those buildings involved in what both evaluation, interrogation of these buildings, and implementation. And then we have our building stakeholders. Obviously, there's, in our case, we have hundreds of buildings, so lots of various stakeholders, whether it's an academic building, a dorm, or a research facility. There's just a number of different folks that play a role in these buildings, and we want to make sure that we keep them in a loop, both not just from a project management and coordination issue, but also understanding their issues and needs within that building. That's where we find a lot of issues in buildings, like temperature control issues, ventilation, other problems that they might have been running into. And lastly, our consultants in National Grid, and when it comes to specific consulting work, say I need a retro commissioning study done for a large lab building, we would bring in outside folks to really supplement our staff and put that whole report together for all of this team to review prior to moving these projects forward. And then when we move projects forward, there's anytime you need what we call further investigation, more work like design work, we would also bring in outside consultants. And obviously various folks from National Grid, our local utility who manages the efficiency programs, really to make sure that we're following the processes right so that we get all the incentives and rebates we're due. And frankly, they play a great role in looking at all of our evaluations to make sure that our savings are correct in there. So it really does provide a great quality control effort to make sure that our savings are appropriate and correct on all these projects. And again, the critical success factor for us is good communication. So that's where we have bi-weekly meetings with our team, internal team, but the tools that we use actually really create a great communication mechanism, and I'll get into that later. So the process. So This is a simplified view of our process here, and what you're looking at is when we start this and we evaluated the campus as a whole, we really wanted to benchmark across our buildings, look at our energy utilization indices for our various buildings, look at the complexity, and start grouping those buildings. Obviously, research labs and their functions and energy use is totally different than a dorm room or an academic building, the hours of operation, all those various things. So we really did that baselining and grouping to see where were our buildings that were really off the charts on energy use that we really wanted to target immediately and get into. And then we did what I call a virtual walkthrough, and our energy engineers, facilities engineers are great folks to help, do that. We're working with our control staff, but really doing a BAS, building automation system virtual walkthrough, looking at overrides, looking at any conditions in buildings that seem to be causing a lot of alarms. So we know we all see that. There's alarm reports, there's override reports, all this great stuff, and you can really get a feel for what's happening in a building, including what are the hours of operation for the building versus what's in the control system, how are they actually operating. And then getting a little more detail and really getting into building level walkthroughs. And this is where you tie into your building reps and your trade staff, really interviewing them and having them part of the process, and then really walking through the building to look for more or less the higher level issues and getting a good understanding of the building before you start really going through an energy audit type process, which I'll get into more detail later. The next piece I talk about here is value stream mapping, and some of you may be aware of this. This is more of a lean principle out there. You hear about lean manufacturing. Well, lean can be provided across, any organization, but we use this lean process to really develop our overall evaluation and implementation at a building level or project or program level. How do we want to go through that process? And we wanted to do that with all the stakeholders in the room together, really to eliminate any waste and identify any communication gaps before we started down the road of implementing projects. And the next is financing, obviously a critical step there. I'm going to explain that later, making sure that you've got a good pro forma developed and that you have the right leadership in your organization to really bring that forward and get that approved. And then really getting into the overall implementation, ongoing commissioning, and then, continuous improvement. This process really never stops. There's always more evaluations to be done, newer technologies, and obviously buildings don't stay working perfectly. After day one of even a new construction project, you're in there tweaking and making things work properly. So we're always going through that. And that ongoing commissioning is really a key piece that we really implemented. It took us a few years to get that up and running just because we wanted to get a bunch of major investments in efficiency done first. So that's not something you do necessarily initially, but you really need to understand it and what's involved early on in the process. So next I'm going to give you a tour of that value stream map, and then I'm going to go through the actual flow diagram that we used in our particular building. So we wanted to make sure we developed a workable process. So bottom line, and this is actually our process improvement documentation here, it really goes through and helps us formalize all of the issues we had when we developed this program. So you can see down below, we've got a current state process map really explaining how we implement projects, a summary chart explaining where we spend all of our time and resources, and then impact versus difficulty, which is great. All right, which are the ones that have the most value, and what's the difficulty level for implementing? You can see we obviously at the top level here, we've sorted these by what are the high value adders and level of difficulty or low to implement, and this obviously goes through all types of issues, and these are what we identified during that value stream mapping exercise where we all sat in a room, we all had our charters out there getting things charted up and with our stickies and going through and really mapping this out for us. And then it gets into what did we learn? So current state value, and then root cause analysis of problems, complex process, team building happen as a natural outcome of that process, important thing. So obviously you're building your team in relationships while you're doing this session. So it's really a win-win. Everyone, and what value stream mapping is, just to explain it, it's simple. It's everybody sees everybody's processes and values that they're trying to get out of that. And so when you've got other consultants or contractors as well as National Grid, everyone has different goals and aspirations and requirements, and everyone needs to see what everyone else needs and find ways to eliminate that waste. So next, I'm just going to quickly go through, this is actually the value stream map in particular that we developed for this process with National Grid. So this is really the rebate and evaluation process. So as you can see, it's pretty complicated, all these various steps, and I won't go into that level of detail here, but basically we're able to take everything we learned in that room together, lay it out onto this visual display, and then really, what did we do? So if you notice this little summary up here, basically it shows that the number of steps in the process we started with, National Grid had 21 steps, we had 28 steps, so total of 49. And lost opportunities, things that we lost out on rebates, as an example, was an example of this $42,000. And one of the challenges we had is we really didn't have a good way for National Grid to forecast how much rebates they would need to be providing when to us on which projects. So we identified that here. The big difference, though, and you can see, is in the future state, we've got now 5 steps in the process for National Grid, 7 for Brown, and 10 of those are shared steps. There's 10 shared steps in there where we both are involved in that, and we narrowed that to 22. So basically, we eliminated all the process waste we had in developing and evaluating projects. So you can see in here, there's, conducting an investigation, engineering team review. We looked for where we could have common performance reports, and then actually getting into implementation and beyond. So the next tool in this process that we developed is what we call B, Brown Energy Efficiency. That was actually a brainchild, I would call it, of a previous process that I used prior to coming to Brown, and but what we didn't have is it wasn't technology or web-based, so it was very manual-based. So we took that manual process, worked with an IT consultant, and developed that into a workable tool that would, understanding that, you got to think this in the long term, is if you're successful in your program, you're going to have hundreds, if not thousands, of energy projects across your campus, whether it's energy efficiency measures or projects, whatever it may be. That's what it takes these days to get the kind of implementation we need. To do that, you really need a good database tool that allows you to track that performance. And we chose something that we felt was workable for us, an Oracle database that utilizes what's called Oracle Application Express. And basically, it has what they call an Apex front end to it, but it's SQL based and really allowed us to, which is all IT jargon, but at the end of the day, it allowed us to take that manual process and turn it into a web application. And it's scalable, extensible, web-enabled tool, so we can expand on this as we need be. We don't have to start over if we change something in the process. We can easily adapt this as we go. So here I'm going to give you a tour of that system. And what I find is this is a system, by the way, that actually will, it has many automatic features, such as email notification, that if there's a project that's related to you in particular, if you're an engineer and it's your building you're assigned to, and someone puts in a new measure and adds in information, you'll get an email when that happens so that you know about it. You'll also get a weekly email, we all do on Mondays, telling us what projects are in our queue. So we don't need a meeting every time we have a project that we need to review. We can actually go through this here, and then bi-weekly we go through any obstacles or issues or reviews that need to happen in person. So if there's more in-depth Q&A or review that needs to take place, but most of that now in our world here is really done in a virtual sense. I'm going to log into this system. So this is where we would get, if normally I'd get an email saying, go take a look at a project. So I'm just going to go to we have various tools. So those tools are, for instance, if you want to compare, say you have 3 chiller choices on a particular project and you really want to compare them across O&M costs and efficiency, we have an IRR comparative tool that will actually do that life cycle comparison. So we can click on this tools button and do that here. What I'm going to do today, just to be expeditious, is this is basically our database of all of our projects here at Brown, and this right now you're looking at is our primary report. So it's going to start with completed. It's got our lighting projects. I just want to look at a particular building, so I'm going to type in Barris here, and it's going to sort this list by buildings. And we have 2 Barris. We have a Barris building and a Barris and Holly, and you can see there's multiple measures. So I'm just going to look at this RCX, a retro-commissioning project that we completed with all its measures. We had spent about $447,000. Our IRR was 10.7% overall. But what we're showing you is this is where all the measures get populated. So you can see in here, we approved this first list of projects. We also had projects we denied, things that just didn't make sense for us. And you can see the summary down below. It gives us what our carbon impact reduction is, what our IRR is, even simple payback, just so we all understand it. And you can see various measures in here. So, for instance, recommissioned plate heat exchanger. So you're going to see this particular project. It's got some estimated costs in here. It's got the energy savings that gets populated. And all these energy rates are pre-populated every year to make sure they're accurate and appropriate escalation rates. So every project is compared with the same math. So there's not a different rate structure, et cetera, across projects. And we even have a rebate tab where if there's a rebate that applies to this, you would say yes, and then National Grid would also be notified, and they would populate the rebate for us. So they have web access to this. So basically, they get those same emails. They're part of the same team, and any contractors that we're working with, like consulting, same thing. They are in the same loop. They don't have to be here in a meeting to do that. And in the general details, the great part about this is it's all your documentation of your discussions, proposed solution, who you issued a purchase order. Not a lot of detail. It's one of the older projects, but any comments that your engineers have, your operations staff have in would all go in here, and it keeps getting up to date and dated, basically, so you know where you are. You could log into this and 5 years after you do the project and know where you were with it last time you were there. And this allows us to provide summary reporting on completed projects that are in evaluation mode, in commissioning, whatever it may be, and you can go through that. Just bear with me here. Oh, I didn't just screw that up. Here we go. All right. So next, I'm going to take you on another tour, and this is our ongoing commissioning software. So we talked about the overall projects that we go through here, and the last thing we need to make sure is that we keep those investments, those savings coming in. I mean, we're saving millions of dollars here, and it's very important that we keep that money coming in. If we put in a new way to control a system or new systems in place, we want to make sure that they keep operating correctly. And we all know technologies out there get more complex with time to help us save energy, but it's also important that we're able to maintain and operate those systems appropriately. So our Brown ongoing commissioning allows us to do that. So we use a product called SkySpark. We've just found that its price point is very reasonable system cost to get a license for this. It's just how you implement their tool. We happen to use Greener U to do our SQL work, and our energy engineers develop all the what we call sparks, basically the arguments of. So here, there's lots of different choices and things you can look at. I'm just going to go in today to SiteSpark, and this is actually a real-time live look at Brown University. So what you're seeing here is all the current sparks that are active, meaning things that have a problem related to them. They're not going to show you the ones that don't. So we'll develop sparks for these buildings for hundreds of items. So say you've got VAV reheat systems and you want to look at simultaneous heating and cooling issue, you can actually set that up. And the great thing is once you've set up one argument, so to speak, you can copy and paste that across multiple buildings. So we've got a process in place to review this, and we have actually bi-weekly meetings, a web meeting with Greener U, Noah in particular from Greener U, where they actually go in and we'll look at some of these issues, and we'll talk about our buildings that we're actually deploying. Obviously, these are up in operation. So we have over, I don't know, 20, 25 buildings up to speed right now. We have another about 40 or so that we're going to spark. You obviously have to have a good DDC system on your campus that you can overlay this on. So SkySpark basically is a tool that will take all that data that you paid for, all that great DDC systems and BAS system, it'll take that data and make really good use out of that data. So we have to we trend all this information and basically look for these problems. And you can see, you know, chilled water bypass. So there's an argument that says in whatever case, or say that the first one, if someone has the occupancy schedule overridden, that's going to show up. So that's for actually 295 Lloyd, that's this building. So it gives me a target for our engineers. Will look at this and drill in, and then they'll actually go look at either the DDC system, or if it's that obvious, they'll put a work order into operations to get these issues corrected. That's where you need a good relationship with your operations staff, because they're really the ones that are going to make this work at the end of the day. And so here's all our various buildings on campus that we have sparked. So these are, all these issues are issues that come up, and it really gives you that visual way to have a transparent method of knowing whether your buildings are working properly. And the worst thing you can do is spend all this money on investing in efficiency and not know if your system is actually operating properly. And you know, logging into your DDC systems and looking for problems is just counterproductive. It's way too much time for what you're going to get out of it. This allows you to narrow that down to any particular building and look for problems. So this tells me that I've got 3 or 4 or 5 issues in a particular building. My guess is that on most of these, there's already a work order in to get it addressed, and then we have basically a tri-weekly meeting with operations leadership to go through anything that's stuck. Obviously, they have other priorities too. The good news here is we've made this is a high-level priority for the university to implement issues so that things aren't sitting out there for months on end, and we track that through our work order system. With that, I'm going to go back to, oops, sorry. There. So, targets and metrics. The next part of the session really gets to, now that you've seen all the technology, how do you set some targets for your campus? Frankly, we took a pretty simple approach when we started this. Is we looked at our overall budget, and we really wanted to come up with a target to meet. Our greenhouse gas reduction goal is that to be 42% below our 2007 levels by 2020. And we knew that frankly, a majority of that was going to have to come from energy efficiency. So we looked at it and said to start. Now, it doesn't mean we're going to stop there, but at least to start, we recognized that in our case, just to make it simple, we're spending about $20 million on utilities. And we said, you know what? We need at least a 20% goal, in our case, to actually get started. And it says, 20% is a balanced target. It says, 10% may be low, 30% may be high, sort of a sweet spot in between. Well, that 20%, very simply, if you just assume a simple 5-year payback at the end of the day, that means you're dealing with, in our case, 20% is $4 million. And now, depending on the rate of return requirements that you have, obviously, if you want a 10% rate of return, you're going to need to spend $40 million to get that $4 million in savings. Consequently, if you have a 20% return, you only need $20 million. And we went into this really with a mindset of understanding that we wanted a minimum requirement that allowed us the flexibility to do longer-term investments. We understand that this isn't your traditional corporation. This is an institution that's been here for, in our case at Brown, 250 years. We know we're going to be here for the long term, and that's a great. As an energy manager, there's nothing better than knowing that you can make long-term investments. So we set a target internal rate of return of 8.5% minimum. So what we did is we guaranteed the university, says, you give me $20 million when I need it, $5 million at a time, $4 million, whatever it may be per year, and I'll guarantee you that we're going to earn 8.5% on that money. Now, we actually pay the university, though, also for that money. They get 3%, whatever the going rates that the university gets for their money, basically. They even make a profit on it, and they charge us a rate for that, and we pay that back with interest on this. But our management knows that at the end of the day, we're actually adding value to the university. So if they can only get 3% for their money, well, I can get a minimum of 8.5%. Reality is, and so far in the program, we started this in 2008. We're roughly at a 20% return. That's just how it worked. As the future goes on, it may drop some as the projects become harder and harder to find, but it really never stops also. So we really give it as making sure that we're performing those life cycle cost evaluations and looking at it from a program level, not just a project level. So I might have a project that doesn't look too good in one building, but if like heat recovery chillers, well, maybe I'm going to do 5 or 6 of those because I really have a carbon goal to make. And when you combine all those, you get your cost to implement down, right? If I'm implementing 6 heat recovery chillers with the same vendor, I've got more pull to get better pricing out of them early on, and those lessons learned as you go through that. So instead of trying to go into every project as a one-off, really looking at it as a program. Lighting's the same way. If you start making that conversion to LED, well, it's a lot easier to standardize lighting products and really source out really good quality products at good prices and negotiate those rebates and incentives on. It gives you that ability to really streamline that process and eliminate any of that waste and variability in your project. And at the end of the day, you still have to keep up with technology. Things do change. You have to keep an eye on what's happening in the market and look where you can actually go beyond where your old systems were. Like, it used to be the best thing in the world to go to a T8 system or maybe even T5. Well, now, after a few years here, now LED all of a sudden is the no-brainer to go after with its controllability and sensing capabilities and web-based capabilities. It's been really a game changer for us now. Now I'm just going to get a little bit about the finance fundamentals. Again, I sort of explained that. What I'm getting at here is really talking about your audiences. We talked earlier about that you've got multiple audiences across university. When you're talking to your operations staff, you get different issues. But when you're talking finance, they're really interested in the transparency of your investments in controlling that budget. And B allows us to do that and provide those reports to them so they know what we're spending when and at the end of the year, they have a pretty good idea of how much we're going to be borrowing from them to pay on that loan and what the savings are generated from that. And in our office, I have full control over that budget as well as the utility budget, so that when I have savings, it can go right to paying on those loans. And you know, visionary investments, control that budget, making sure that everyone really understands where you're heading. You know, that 5, 6, 7, 10-year plan of investments and control over that. They need to know that someone's actually managing the budget process in here, which that tool B really allows us to do and approve projects as a team as we go through. We also have a quarterly principals meeting, which really is about two things: financing and any obstacles or issues or resource issues that we have in the projects. So that's our vice president of facilities, our finance person here, as well as the lead of our project management team, PD&C group, as well as our internal project manager and myself. And lastly, having a loan payment or cash flow, you know, understanding how that process works, and we do that once a year with this, but we started with what's called a pro forma. So we laid this out for our executive VP of administration and our head of finance. Say, here's how, in a nutshell, we're going to finance and manage this project. So I'm going to quickly go into this tool. We've still got some time, so I'm going to make sure we hit this well here. So this is the tool we created, and this is just an Excel tool that our finance folks use, but basically it has each fiscal year for us, and you can see we've got completed years here and spend into the future. So these are our estimates going forward, and if you take a look at this here, these different tabs, this is for each year we finance. So basically it's a simple P&I statement for here's your savings, your total cost that you're spending, your refi rate, et cetera, and then basically financing this debt service over these projects. So we've done this every single year, and that totals off into this page here, so you've got each fiscal year addressed. And obviously the university, this is key to them, is understanding the cash flow and where the savings are going to come from, which is this line here, and making sure you always have that here. And at the end of this, it just gets into more of the your totals, right? What are we going to spend? So totally, we actually have roughly identified so far $32 million in energy efficiency investment. Remember, when we started, we said we were going to spend $20 million. We're already at 30, and we're probably going to go upwards of 40. It really depends on the IRR requirements, and we're still meeting our 8.5%. We're obviously at 20, so we got plenty of room to take on some of those longer-term projects that are out there. And then the other important aspect to this too is the when these loans are paid for, like I said earlier, we've got multiple stakeholders out there, one of which is our very important, our vice president of facilities. So when we were selling this program, I had to sell it to him too. And one of the values that's important to him is he needs to keep this campus well maintained and deal with deferred maintenance. So what the agreement was is when I paid off a particular loan, I would transfer that money, because I don't need that savings anymore, right? That's an annual cash flow. We transfer that money to our renewal budget. Basically now we have transferred, we are saving roughly $3.7 million a year in savings, but I've already paid off the initial loans on this, and I've transferred $2 million of that into renewal. Our renewal budget was, several million. So basically, I've been able to increase that by more than a third. So that helps everybody on campus. It helps our operations staff, because now they've got newer equipment out there that they've been, patching together for years. So you've got to our VP's got a major role in that, but then our operations staff too. And that's really gets into this last piece of this, which is selling the program. It needs to fit their vision, not your vision, right? So I'm selling our program, but it's got to fit their vision. What's in it for operations? What's in it for the building staff? Well, better control their buildings, less problems in their buildings, right? We're actually going to fix controls, fix systems while we're there. That's what retro commissioning piece of this is all about. And then we're going to work on those future systems that weren't around when these buildings were designed and implemented. Again, adapt it to your audience. Prepare to answer their questions. Come ready for that. Expect them to be asking tough questions. If they don't ask questions, you got a problem. You don't want them just sitting there. You actually want them to bring in any problems or issues and say, well, you know, what are you going to be installing for lighting? How am I going to maintain that? Do we have the budget to handle that? And really getting into all those types of issues here. Right now, frankly, with LED, these guys are really on board because they love the fact that these systems are really going to last much longer, and they're not going to be dealing with a relamping issue like they do with fluorescents right now. Again, what's in it for me? What's in it for these guys that they get out of this? Somebody wants something out of this, whether it's better systems, less, calls, more money for preventative maintenance and renewal money because we've actually transferred savings to those programs, you name it. So in a nutshell, lessons learned in the future vision at Brown. So again, talking about the biggest lessons learned is developing that buy-in, making sure that everybody's on the page, whether it's our biomed staff or academic staff and buildings. Integrating it with operations is key, and having your senior management think like financial managers, understanding what IRR means and net present value and discount rates and cash flow and pro formas, not just talking about paybacks and individual projects, really thinking like a financial manager does, because those are the guys really who at the end of the day are going to be investing in this and getting you that capital you need to make this happen. And for future vision, we're looking to approach net zero. What do we got to do to approach net zero? And that involves renewable energy investments off-site, as an example. We're going to be looking at that. And the other key area for us, and now this depends on where you are in the country too, where it's some places it's easier, some places it's harder, but really recovering that waste heat in your buildings to reuse that. We're never going to get our internal energy use, obviously, to zero. We're here to teach students and do research. That's not going to happen, but we can certainly invest in renewable energy projects. The financial aspects of those have really gotten better, and there's multiple ways you can skin that cat and bring in investors into that pool and come up with a strategy to look for some of those investments, whether it's solar or wind or other off campus.
Great. Thanks, Chris. We are going to target getting out of here on time at 1 o'clock, so we've got a number of questions. We're going to try and stick with relatively brief answers, but we still have room for more, so if folks want to shoot questions over while we're chatting here, we may be able to squeeze them in. Chris, while you were talking about SkySpark, a number of questions rolled in related to that. First one up is, do you have a mechanism for tying a specific spark with an energy value? You know, how much energy waste is associated with this spark?
That's a great question, and it actually when we started this, that was our biggest obstacle, is like, how do you do this? So what we did is we sat in a room and we looked at multiple types of sparks that we would run into. And we basically said, let's take them individually and create a just an order of magnitude savings impact ranking for those. So we might have, say, $3 signs or $4 signs for the big savers, and then $1 sign for the least. And that was really the way we started with this. And it was really to get us going and get rid of the bureaucracy, but understanding that, remember what we do though is we still, for anything beyond $1 sign, we actually will do some level of energy analysis on that. We've actually taken it a step further now, is with National Grid's help, they've taken a look at all of our sparks that we've done and created, and we track them in B, by the way. In B, we have all the IRR and all that stuff built in there. Remember, the quick hit stuff that we were finding, though, we don't stop those projects. If it's $4 signs, and in some cases, we'll actually do all that evaluation, by the way, for the big savers automatically. So we do that energy evaluation of that particular issue immediately if we know there's significant savings. But what National Grid has allowed us to do is they've actually developed a tool that standardizes that evaluation for all these different measures that we have. So we basically took our entire list of sparks that we've implemented since we started the program. We sorted all those out and really came up with a standardized approach to easily calculate those savings and put that math in. And if there's heating degree days or cooling degree days or other efficiency information, we documented all that. Like, we know all of our satellite chiller plants, we know what their COPs are, we know what our central heat plant efficiency is, we know what our other systems are. So we're able to build that into a model that allowed us to use the same tool over and over again. That standardization is critical in this. But frankly, when we started,
we're going to try to move on because we got a few more stacking up here. Sorry to cut you off there. I'm going to compile a couple together here. So it sounds like you are quantifying savings. Do you have sort of a sense of the overall magnitude of the savings from SkySpark? And along with that, what kind of financial justification have you gone through for that, and what kind of return on investment are you seeing in the ongoing commissioning?
Yeah, that's a great point. And to be frank, it's become the mechanism that's helped us keep that 20% rate of return that we're getting. And the reason is that a lot of our standard projects now are having higher payback. So there might be a 10-year payback, right, out there, or even longer. But the ongoing commissioning has actually allowed us to, the paybacks are so quick for us that we're using that savings to help pay on our overall loans. And now remember, the agreement we have here, though, is operations has to implement things that are their problems to begin with, right? So it's not actually costing us anything when they're out recalibrating a sensor or doing something that normally would be part of their job anyway. But if there's, say, we go in and say, well, we need to add controls in a particular system or temperature sensors on discharge of coils or something, we will actually pay for that. But at the end of the day, I'm going to throw out rough numbers. I don't have it in front of me, but we basically have spent maybe $150,000 in the first year or so in the program, and we've saved about $375,000 a year in savings. Now, this is the really cool part, by the way. Working with National Grid, we have a strategic energy management program plan in place with them, and it pays us on savings, not costs. That means that $375,000 with the current rate we're getting, we were actually paid more than we paid to do the measures. So that $375,000, we actually are getting a $500,000 rebate from them for those projects. The reason they can do that is that they combine that with all of our longer paybacks so that they're actually never paying us more than the original costs, because you've got the big capital projects combined with the quick hits into one. So it's actually a no-brainer out there from a financial perspective.
Great. Shifting gears a little bit, in terms of selling to the finance office, what were the keys to sort of winning the day in that, and what were sort of the biggest hurdles that you faced?
I would say the biggest hurdle is past performance. Before I got here, the issue of, well, how do we know what the savings are going to be, that they're really going to occur? And so you've got to be able to be confident enough in your own ability to get these savings. If you're not confident, you're not going to convince them, without a doubt. And I think that and the transparency of our system, understanding that they're always going to be to know on a quarterly basis anyway what we've done and how we're performing. So they always know that if they need to ask a question about how we're doing, that data is readily available and transparent to them in our tools. Great.
In terms of the way you're running the program, how much are you doing in-house? You had mentioned use of outside consultants. I guess question really gets to both how much are you doing in-house versus going out of house, and what are your guidelines for making those decisions?
I would say we adapted over time. In fact, we started out more with a consulting mode when we began this. Although we had, facilities engineers who were part of the process, our consultants really were driving the projects forward with us. Over time, we've adapted. There was a reorg here, and there was a couple of those facility engineers that were positions were eliminated. So I used my savings in the program for the ongoing commissioning piece to actually justify paying for them through my utility budget on there. So it's a sweet spot. What can you cover on your own? The rest of it is really covered through the loan process, right? These guys are actually a normal cost of my doing business every year. So it's 2 energy engineers that are really being paid for by my utility savings piece, and then the projects themselves just have to make sense financially, and that's all consultants. But I would say we moved to more of I would still say we do probably on regular projects, not ongoing commissioning, but regular projects that we implement. Our engineers are doing probably 20% of the work, 80% is through consultants and et cetera, which are all incentivized and paid for in many cases by our utility provider, National Grid. But then the ongoing commissioning is really more our people doing that and our operations staff implementing, so there's very little consulting per se except for the SQL piece that we use from Greener U.
Got it. Okay. Again, I'm going to try and consolidate a few here. You mentioned there's a couple of questions about the costs associated with SkySpark, and also so what is that costing you on an ongoing basis? What other software did you evaluate, and how did you ultimately settle on SkySpark?
Yeah, we looked at several different packages at the time. Well, a lot of different models, in fact, of how to do it, like Symmetrics, and there was, Enernoc had a product of their own, but it was more of a shared savings arrangement. You didn't own it. And then, Johnson Controls has their own, and there was, and I'm going to forget the name, but there was another product that you could buy, basically, and develop. Frankly, for us, we like the idea of investing in it, and then we get to keep the savings ourselves. So we spent the money to develop these. From an SkySpark, I tell you, it's a no-brainer. That system, we're spending, the license fees and costs for the software are really inconsequential. I would say when we started the program, we were probably spending maybe $2,500 a year. Now we're probably spending, I don't know, maybe we're up to like $15,000 or $20,000 initially to buy it. But then you're licensing. You buy basically a package of data points, basically how far you're going to go. And I'm not the IT guy, so I can't explain it as well as Greener you could. But when you spend that money to buy all those future points that you want to do across your whole campus and do, it's a one-time investment of, say, $15,000, and then you pay like $1,500 a year in maintenance costs, basically to upgrades of the software and anything else that comes out for updates and to use that system. So it's really a very inexpensive system. The key is you need to, someone internally or consultants needs to identify what the sparks are that you're going to evaluate, and we do that internally ourselves here. We have a process we've developed to evaluate these buildings, looking for problems, very much like an energy audit in a way, but obviously getting into the nitty-gritty of our DDC system and our drawings and looking at what our sequence of operations are and set points and all that. So we go through that, and it really streamlines very quickly, because after you do a few buildings, like lab buildings, all the points are relatively the same. So it's like copy and paste. It's just a different DDC identifier for that particular VAV reheat or that air handler or that heat exchanger or whatever it is you're trying to monitor. You can even monitor preventative maintenance type items like differential pressure if your operations staff wants to look more predictive maintenance than, you know, scheduling maintenance.
Great. I think we're going to call that a wrap. If we could move on to the next slide. We've got some logistics just in the wrap up here. We've got a survey. If we could get the next slide.
Oh, sorry.
Yep. The next slide. Thank you. There's a survey that will be open after the session ends. We're always trying to improve on what we're doing here, so if you could take a couple minutes to fill that out, we would greatly appreciate it. And as we mentioned at the outset, we will be posting a recording of this shortly, and we'll send around an email to let you know when that's available. And the last slide. That's all we got. Thank you very much. We really appreciate you coming out, and thank you, Chris. That was a great talk and very engaging and fascinating. Thanks.
Thanks, folks.